will divide large network into a smaller network?
According to the nodes and hosts.
Why? Private IP
Sir,
addresses are free, reusable.
sir, for better performance or security, so that we
Better
can implement different kinds of policies for different verticals. For that
Right.
purpose,
I have told you we divide anything to make it easy. Right. So we will perform subnetting to get the sufficient amount of IP addresses for our network. And if we will divide large network into a smaller part, then we can easily perform summarization. We can summarize the routing table of router as well. Right. After that, there are a number of other benefits. So subnetting was the benefit of process of dividing large network into a smaller network. From class C, how many host bits are there for IP addresses?
eight
8.
Two.
Right. Means
Uh,
total
2 to the
24
power
network bits are there. Means how many IP addresses are there?
two five four
256
254 usable overall
254.
to bits.
Correct.
Yeah.
25
usable.
254 valid IP addresses. Valid
Sir, are
IP.
you recording today?
Yes, I am recording today. 254 IP addresses available in class C. In class B,
2 to the power 16 minus 2.
2 power 16 minus 2 IP addresses are available in class B by default. And in class A,
2 to the power 24 minus 2.
2 power 24 minus 2. Right? So huge number of IP addresses are available. And if you want to divide a network into two parts, what is the logic behind it? How will divide? By increasing the number of network bits. By increasing the number of network bits, like if I will ask you 192.168.1.0/24 is my main network, divide it into 4 part. Divide it into 4 subnets. How you will do that?
Borrow host bits.
We have one formula, right?
Yes, 2 to the power n.
2 power n, where n is
Number of borrowed bits from host.
Overall bit.
exactly, right? It is going to give me the subnets, total number of subnets. So what should be n here? If I need 4 subnet,
2.
n should be 2, right? Means my new CIDR value or slash value is going to be what?
26.
It is going to be
26.
26, right? 26. We have borrowed 2 bits. Now let me ask you one more question here. This is the subnet, main subnet, IPv4 main subnet 192.168.1.0/24. First, I ask you to divide it into 8 parts. Divide it into 8 parts. 8 subnets. Question number 1. Divide into 8 parts. After that, here are some questions. Okay, this is task and then question number 1. Tell me third IP address of second subnet. What will be the third IP address of second subnet? Broadcast ID of last subnet. Number, there is noise, please put yourself on mute. You can type in chat. If there is noise from your side, please keep yourself on mute. Number of valid IP address per subnet. Right, in one subnet how many IP addresses will be there, valid IP addresses. And one more thing, let's suppose the network ID of last subnet. Okay, so I need to find these all things for this main IPv4 address. So you know, if I will divide it into 8 parts, that means how many bits I need to borrow. My n is going to be what?
3.
3.
N
3.
is going to be 3. So my new CIDR value is going to be 27.
27.
For 27, subnet mask is going to be 255.255.255 dot
2 to 4.
224.
2 to 4.
Correct. Block size is going to be what?
256. Minus
256
2 to
minus
4.
224.
32.
It is going to be
32.
32.
Right? Valid host per subnet. Valid host per subnet.
Is it
30.
30, sir?
Yes. Total
30. Yes.
length of network
Yeah,
is
okay.
32. So it is going to be
32.
30. Right? Now first network will be the same one, which is here. First network 192.168.1.0/27. Second network 192.168.1.32/27.
32.
32. Yeah.
32.
Third network, third subnet,
64.
64.
fourth subnet,
128.
128.
no,
Class 27, sir.
fourth network
96.
96/27.
96. Okay.
Fifth network, fifth subnet,
128.
128.
great, 128. Sixth network,
160.
Yeah, 160.
160/27. Seventh,
192.
192/27. Eighth,
2 to 4.
224/27. Ninth,
256.
256/27. Is it the valid? Is it a valid?
No.
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 No,
No,
it's
sir.
used
No, no,
up
no.
224.
Right? This is invalid.
252.
This is my last subnet.
Okay.
So last IP address of first subnet is going to be what?
1.31.
Let me take it here. Yes, last IP address.
1.31 broadcast.
31. 30, sir. 31 is broadcast.
192.168.1.31
Yes, sir. 31.
/27. 192.168.1.63.
63.
192.168.1.95.
97.
192.168.1.127.
27.
192.168.1.159. Hello,
191, sir.
is it correct?
159.
Last IP address of fourth network, fourth subnet. Next network is starting from 160. So definitely it will end on 159.
159. Yeah.
Then 190.
1.
1/27 and 192.168.
223.
223.
223.
223 and then
No more. You
No more.
stop.
255 / 27. Correct? First
Yeah.
network, first
The
subnet,
first
first valid
Sir,
IP address.
you got the first two incorrect in writing. They're
Right, right. It will be
yeah.
31.
The first one's
Okay,
31
okay.
slash
It is
27 and the second one should be 63.27.
it is going to be 192.168.1.31/27, and this one is also incorrect. Okay, 192.168.1.63.
63, yeah.
Yes, sir.
Yes, first IP address, first valid IP address. These are not usable, right? These are
Not usable.
network ID,
Network
and these
ID.
are broadcast
Broadcast.
ID.
Broadcast.
Broadcast.
So first usable address is
192,
192.168.1.1.
1.1.
192.168.1.1,
1.
and last is
1.30.
192.168.1.30. This is the last usable IP address from first subnet. From
Yes,
second subnet, 192.168.1.33,
33.
33.
and last IP address
62.
62.
62.
192.168.1.62.
62. Third subnet, first valid IP
192.168.1.65.
last valid IP
192.168.1.94.
fourth subnet, first valid IP
192.168.1.97.
sorry 97, and last valid IP
192.168.1.126.
126.
192.1.126, 192.168.1.127.
120. 120.
Correct na? 192.168,
120.
120,
129.
sorry
129.
129, 129, and last IP
158. 192.168.1.158.
correct. 192.168.1.161,
161.
161.
and last IP
192.
190.
168. 1.119.
sixth subnet 192.168.1.193,
192.
and last IP
192. 168. 1.222.
last subnet
Oh, you wrote me. 222.
Missing. There we go.
Typo. Still a typo.
255.
You got five. You got 5 octets there. It should be 192.168.1.22. Yeah, thank you.
192.168.1.254. These are my usable IP addresses which can be configured on
Host.
devices. Here is the mistake. This one is 225. 225. So guys, we can configure these IP addresses on devices. Now check the questions. Third IP address of second subnet. Tell me the answer. Third IP address of second subnet. Second subnet is this one, network ID. First IP address. Second IP address will be 34. Third IP address will be 35. Right, so 192.168.1.35 is the answer. Our first question. Broadcast IP address of last subnet. Correct? 192.168.1.255.
5.
Number of valid hosts per subnet.
30.
30.
30.
Valid host in all the subnet is same, 30. That's why this is FLSM, fixed length subnet masking. And yesterday at last we had also talked about VLSM, right, where length was
VLSM.
variable. Number of valid hosts done, then network ID of last subnet 192.168.1.224. Now if I will ask you directly question like this, that this is the main subnet 192.168.1.0/24, and tell me the, or like this 192.168 dot, let's suppose 1.100/27, what is the network ID of this IP address? What is the network ID of this IP address?
That's 192.168.1.96/27 address. There'll
Look
be
at
like a
this
fourth
table and
subnet.
then tell me.
That's the fourth subnet.
Fourth subnet, right?
Yeah.
But if this table is not in front of you, then how you will find the network ID quickly? Any idea? If this table is not in front of us, then how I will quickly find the network ID of this IP address?
Yes, sir.
Yes, tell me.
It's by subtracting the 32 by 27.
How you will find the 32? Let's suppose here is the question. 192.168.1.100/27. Tell me the network ID.
What this?
Tell me the network ID. My God. Network ID. See, to find the network ID, you only need block size. Block size. See, by looking at this IP address, I can identify one thing, that how many bits I have borrowed. If IP address is like this 192.168.1.100 and /24, then very easily you can tell me the network ID, right?
Yeah.
Because in last octet all the bits are 0, so value is going to be definitely 0 in fourth octet. But here in the last octet value is not 0, value is 1, 1, 1 and 5 times 0. Means we have borrowed how many bits? 3 bits. And for 3 bits, we know subnet mask is 224. So my block size will be 32. Now you
32.
need to find a divisible number just before 100. Divisible number by 32 just before 100. That will be your network ID, yes or no? The number which is divisible by 32 just before IP address 100. I can do one thing, I can divide 100 by 32. 6.
96.
What will be the value here? 4. I can subtract 4 from the 100. So 100 minus 4, it is going to be 96. Means my network ID is 192.168.1.96. Is it the same network ID? Yes. Correct? You need to find number which should be divisible by your block size before the IP address. Another question. Let's suppose 192.168.130/25. Tell me the network ID. Yes, tell me network ID. Use the same formula. Find the block size. How many bits I have borrowed? Means
1
10
bit.
within 20 to 30 seconds you need to answer. 20 to 30 seconds you need to answer. So tell me how many bits I have borrowed.
1.
What will be the
1.
subnet mask for 1 bit? 128. Block size is going to be what? 128.
128.
Divisible number by 128 just before 130 is going to be 128 only, right? So my network ID is 192.168.1.100.128. But most of the time people are saying network ID is 192.168.100.0. No, right? Like another question. Let me type through keyboard. 192.168.10.
Praful, sorry to interrupt you. What you did, you have find out the block size, and then you have divided that number, right?
Correct.
Just can you repeat once again
Yeah,
what
yeah,
you
I am
have done?
repeating only here.
Yes, yes.
192.168.10.80 and slash 28. Tell me the network ID. So how many bits I have borrowed? 4 bits.
4 bits.
Yes, sir.
Block size is what? 248.
10.75.
Not 75. Block size is 248 256 minus 248.
Yes, right.
What will be the block size? 62. I said just divide 80 by 62. So if you will divide 80 by 62, what value? 1 here
So
and here
62,
62.
how you got
How
62?
62?
This is block size.
250, the
Sir,
block size
256 minus
Sorry,
minus 248.
it is going to be 32.
No, no.
2 to 4, sir. Block size will be 240, I think. 240. 4 bit
I
लिए.
have borrowed 4 bit. So it is going to be 240. Yes, sorry.
240.
256 minus 240.
Right,
16.
right.
Block size
16.
16.
16.
Right. Now I need to find the number which is divisible by 16 just before 80. That will be my
But
network
80 is
ID.
like this totally divisible by 16. 16 5 is 80.
So this is not valid IP address. That means if the number is divisible by your block size, that is what? That is network ID, right? That is
Okay,
not
so
Yeah.
this
valid
is the
IP
network
address.
ID.
If your number is divisible by IP address, that means it is not IP address. It means it is
It's a
subnet ID.
yeah.
So is it the subnet ID or valid IP address?
It's a subnet address. Yes.
Subnet address.
sir,
Another yes.
sir, please, Miss Raji, please mute on mic. सर आवाज क्लियर नहीं आ रही है इनकी.
Yeah, I'm also getting some noise. Chari, please keep yourself on mute if you are not speaking. There is noise from your side, brother.
So subnet
Okay.
ID means the network ID, you mean, right?
Yes, network ID of your small network which you have divided after subnetting.
Okay.
Okay. So again, if I will give you one more question, 192.
Praful, can you explain one more time? So
Yeah,
slash
I am
28
explaining one
means
more. That's why I'm giving you the another question. Na? 192.168.10. This time I am saying 86/27. Tell me the network ID.
yes to borrow uh, 3 bits.
3 bits. So what will be the subnet mask?
224.
224.
Yes, sir.
248.
Subtract block size from 256. Sorry, subtract subnet mask from 256. You will get the block size. So
32.
32. Now find the divisible number just before 86. Is 86 divisible by 32? If yes, then
No.
this is not IP address. Then This is network ID. If no, then tell me the divisible number just before 86.
64.
64.
As according to 32.
Exactly. 64 is the network ID. 192.160.10.64/20
8.
7.
Oh, 27. Okay. Yes.
Hello,
Yes.
sir. How to divide it? Divided formula, sir. It
Yeah, even if you could give us the formula, since my first class, I'm just trying to figure out what's the formula you're using.
192.168.10.100/26. Okay. So tell me what will be the block size. What I told you, to find the network ID you need block size only, nothing else. Only block size is required to find network ID. And to solve the submitting question you need network ID only first. So what will be the block size? I have borrowed 2 bit, means subnet mask
64.
is going to be 192.
64.
64.
64.
Block size will be 64. Now I need to find a number which is divisible by 64 just before 100. It is going
64
to be
itself.
64 itself only, right?
Because
So
if we
64
if
is your
we
network
multiply.
ID. If you are not
Okay.
able to find the number, divisible number just before 100, then you can divide 100 by
Praful, can
64.
you please explain the calculation before that block size?
Is it your first class?
No.
Okay. Block size formula is 256 minus subnet mask of last octet. Last octet means where last one is present. So in which octet last one is present if I am using /26? /26 means what? Means in first octet all the bits are 1, in second octet all the bits are 1, 8 plus is 16, in third octet also all the bits are 1, 24, and in fourth octet how many bits are 1? 1 and 2. And 6 are
0.
0, right? So what will be the decimal value of this binary? (128 plus 64)
192.
192. This is subnet mask of last octet. Now to find block size I will subtract it from 256. 256 minus 192, I will get block size. Got it?
Yep.
So tell me what will be the block size? 256 minus 192?
64.
64. And
So,
find the,
Praful,
yeah,
the network ID is nothing but the first network of the subnet,
first
is it?
IP address.
First IP address. I
Yes,
mean, the network IP.
network IP.
Okay.
And sir, I guess we can do one more thing is, as like you said, the BS is 64. So just simply if we just turn on and just 2 ka power n is if we say so like 2 power 6 equals to 64. So that is totally the BS. 2 power 6 equals to 64. 2 power 5 equals to 32. 2 power 4 equals to 16.
So based on valid host.
No, yes, like you said, for this /26 we have 2 bits on. And if we calculate like 2 powers according to this, so we have 6. Like because 2 bits are on, so we have only 6 left with us. So 2 power 6 is equal to 64. Then it will be the BS as well.
See, block size, yes, valid host plus 2 is the block size only, na? Total
Yes, sir.
length of network is the block size only. And so many other ways are there. Even if you will practice a lot, then you don't need to calculate. By looking into the IP address, you can tell the network ID. Like if I will give you the default subnet mask, then are you going to perform AND operation or going to convert anything in binary? No, you will directly tell me the answer. So this is logic. I want you to understand the logic. How I am calculating the network ID. So within 10 to 20 seconds, you can find the network ID of IP address. Now, 172.16.10.100/26. Tell me the network ID. One 172.16.10.100/26. How many bits I have borrowed?
2.
Not 2.
2 bits.
10 bits,
bits.
10
I have
bits.
borrowed
Yeah,
10 bits, yes.
24.
But in last octet, how many bits are there? Only 2.
2
Right?
bits.
So subnet mask of last octet is going to be 192 only.
192.
192. So my block size is going to be
64.
64 only.
Okay.
Block size is 64.
Mm-hmm.
So what will be the network ID?
172.16.10.64.
170.16.10.64. Yes.
Is this correct?
Yes, yes, absolutely correct.
So like this is the class B IP. So I believe like first two this octets will be like stable. Like we cannot change 172.16, but this should be 0, no? If we can
But you
change
need
it.
to find the network ID of this IP. Na? I am not asking you tell me the
Okay.
first network ID.
Okay. Now understood.
Yes, 2 power 10 networks are there. Here I have divided big network into 2 power 10
10.
parts.
Mm-hmm. Understood now.
Now let's solve those subnetting questions from the PDF ones, right? You guys tell me answers. If you will share the correct answer to all the questions, then I will move to next topic, because now there is nothing in subnetting and VLSM.
Could you share questions for all the classes so far, since this is my first class? Would just like to have those and work on them as I go.
Yes, yes, definitely.
Okay.
Yes, let's start from the first question only. Here it is. Yesterday also I had solved this question. Maybe this is IP address or network ID or broadcast ID. For now I don't know. This is a valid IP or a broadcast ID or network ID. But we can see here one thing, /20
7.
7. So /27 means in last octet how many bits are 1? How many ones are there?
3.
3 ones are there,
3.
right? So subnet mask of last octet is going to be
224.
224. So my block size is going to be
32.
62.
32.
62 na? 62 or 32?
32.
32. 2 power 5
32.
equals to 32.
32.
32. So now tell me,
Yes.
this is a valid IP address or broadcast ID? Yesterday you guys said this is a valid IP. So I think broadcast ID or network ID, I don't remember. Whatever. Now tell me, if block size is
Hackers, can you mute yourself, please?
if block
There's
size is
too much
32.
noise.
No, I have to remove only. I don't have any another option. So if there is noise, you have to keep yourself on mute, guys. Block size is 32. Then this is a IP, a valid IP address, network ID or broadcast ID. Just divide this number with
Network ID.
block size. So 32 plus 32, it is going to be 64. No, this is not network ID. If this IP address is
This is the
divisible by
valid IP,
block
I guess.
size, if it is divisible by block size, then only this is network ID, correct?
Network model, correct.
But it is not divisible. That means this is not network ID. And if my block size is 32, my first network is going to be .0, then .32, then .64.
64.
and so on. And here we can say if this network 32.32 is starting from here, it will end on dot 63. First IP
3.
address will be dot 33
33 to
dot
62.
33 to dot 62, right? So this is last valid IP address of this subnet 192.160, sorry, not 192, 10.86.86.32. This is the subnet
Hello.
ID. This is the subnet ID of this IP address, and now it is asking you the last IP valid IP address. So last valid IP address is dot 62, means option D is your correct
D. Yes, yes.
answer. Second question, calculate it. What is the maximum number of subnets and host per subnet, valid host, for this IP and this subnet mask?
C, sir. 8 subnet.
Right, here we can see we have borrowed 3 bits, means we will get 8 subnets, and there is only one option for 8 subnets, which is option C. I don't need to calculate valid host. Even you can calculate valid host as well, you will get the same number, because formula of valid host is 2 power h minus 2. H is how many
5.
host bits are there? 5 host bits are there. So 2 power 5 minus 2, 32 minus 2, 30. Great. Let's move. How many usable IP addresses can be assigned to host on /26? If I am using /26, then how many usable IP address is there?
62.
/26 means how many free bits are there? How many host bits are there?
6.
32 minus 26, 6. So 2 power 6
Yes.
minus 2 power 6 minus
62 only.
2.
Option
2
C
power
is the
6 equal to 64 minus 2 equals to 62.
option C is the correct answer, right?
Yes, sir.
Next question. Which of the following answer list the decimal notation of the binary 1115 times 0?
2 to 4.
2 to 4. B.
Just subnet mask, right? 2 to 4.
D.
Correct. There is a router. A router has the following IP address on Ethernet 0 interface. Its 0 interface is using IP address 172.16.2.1. Which of the following can be the valid host ID on the LAN interface attached to the router? Now see, this router interface is connected with one switch, and here is the host. So which IP address can be assigned to the host? Tell me.
2.255C.
This one.
Yes, sir. Because
What
one
about other?
it is increased by 1, so next network is 3.0. So usable will be
But I guess we cannot give a IP 2.255 to any PC or any like LAN interface.
Why?
it is part of that only.
Okay, tell me block size.
128.
One will be there, no?
How many bits I have borrowed? See, this is class B IP address. Default one is 16. Tell me the subnet ID or block size or range of this subnet from which this IP address belongs to. You can calculate anything to find the correct option. My subnet mask is going to be 254.
255.
Not 255, not 254, I think.
Yes, we have 255,
254. So
255,
block size will be
1.
1 or 2.
2, sir, 2, yes, 2.
Block size will be 2. Means my first subnet is 172.16.0.0. Second subnet is 172.16.2.0. Then 4.0. 172.16.2.0. Sorry, 0.0. Last one is present in third octet. Slash 23. 172.16.2.0 slash 23. Now you tell me this IP address belongs to which subnet? This network is ending on 1.255. Next network is going to be 4.0. So this network is ending on 3.255. Now tell me this IP address belongs to which subnet? This subnet or this subnet? 2.1 from this subnet, and here is the range of your subnet. Tell me any one IP address from this range. 170.16.1. No.
Option D.
Option D is the correct answer. Here is value is here 0. Can I configure this on the router? Another question. Can I configure this IP address 172.16.3.0 slash 23? Will router accept this IP address?
It should accept, it's a part of that network.
How many of you are saying it will accept or not accept?
It will accept.
It will accept.
All are saying it will accept. Anyone who is saying not accept? Three dot zero submit mask.
255, 254,
254.
254.
Mm.
254.
No, it's 255, 255, 254.0 because you're doing a slash 23.
254.0, sir. Third wala.
Third octet should be 254, yeah.
Yes.
Yeah.
So if subnet mask is correct, then it is accepting the IP address.
Yeah.
This is valid IP address.
Yeah.
Where is the question here? Next question. What is the broadcast address on this network? First tell me this is network ID, valid IP or broadcast ID? Subnet mask is here. 3 bits is borrowed.
This is network ID.
27.
Block size. Only you need to find block size. Block size is going to tell you the answer of everything.
32.
Slash 30 and 32.
32?
Yes.
So
32,
32
yes.
plus 32, 64. This number is
The
divisible by
network
my block
address.
size. Means this is network ID. Now what it is
Yeah.
asking? Broadcast address. So next network will be what? 64 plus
96.
32, 96. Means last IP
Yeah.
address is going to be what?
95.
95.
Yeah.
Broadcast ID means option B is the correct answer. Clear?
One question, sir.
Go
Like
ahead.
you said, this is the block size is 34, 32, and it is totally divisible by the 64
IP
is totally
address.
divisible. So then this should have to be, yeah, this should have to be the broadcast, no? Because for
This should
each
be the
subnet,
network
we do
ID.
have one network ID.
That's the network address.
Okay.
This
Okay,
should be
so
the
okay, this is the network
and next
domain
network will
that
be
is
dot
near to the next.
96.
Yes,
So this network will end on dot 95 only, right? That is broadcast ID.
dot 95. Yes. Okay, noted, noted.
Say question number 8. Valid host range. for this IP and CIDR. Total number of valid, not total number, valid range. So again /27 means I have borrowed 3 bits. My
Yeah. So
block size is going to be 32.
yeah.
Block size is 32. Now what is the network ID? Network ID. You can divide it. Here if you are not
224.
able to calculate, then you can divide. What will be the
220
network ID?
224.
224. And next network? 224
225.
plus 32.
It will be 256.
256, which is not, that means this is the last. This IP address belongs to last subnet, correct? We
Yeah.
have total 8 subnet. Out of 8 subnet, this IP address belongs to last subnet. So range will be what? Dot
225
224
to
dot
255.
255. Which option is the correct option?
D.
D. D. IP address is starting from here. This is perfect, but is this a valid IP?
It should be option B.
Dot 255 is the broadcast one.
This one is the broadcast. So don't you think option B is the correct answer?
For me, it's
Yes,
B,
sir.
yeah.
Yes.
Yes, sir.
For all
Yes,
of
sir.
you,
Go
it
over
will be
once
B.
once more.
Once more.
Superb.
Yes, sir.
No,
This
one
question.
more
This
question.
This is IP address. Here you will find the network ID. Your network ID is going to be 192.168.187.224. Right? And here if you will add the block size, then you will get next network, which is going to be 256 invalid. That means this network will end on 192.168.187.255. Now it is asking the range of valid host. So valid host range will start from 2252, it will go till 254. This will be the range of valid host. Option B. Question number 9.
Praful, can you please go to question number 7 or 6?
Okay.
Yeah, in this option C and D are both are correct, right?
If both are coming in the range, then both are correct.
Yeah, but you said like D only.
So
But
doesn't matter what
both
I
are correct.
said. If both are in the range, then definitely both will be correct. I have not
Yeah.
checked option C is in range or not. If it is in range, then it is also correct. What is the valid? First valid host on subnetwork, that again this is the IP address, and tell me the first IP address of subnet from where this IP address belongs to. One bit is borrowed.
225, that one.
Block
C,
size is
option
going
C.
to be 128 only. That means network ID is dot 0 172.20.225.0. Second network dot 128. So first valid IP address. Option C, right? Dot 0 dot 1. First valid IP. Yes or no?
Yes, sir, got it, sir.
For
I
all
guess
the
I need to maintain a chart for this slash 24 to slash 32. Then we
yes,
can only
correct.
remember this one.
Correct. Then only you can find the subnet mask. If you have subnet mask, then only you can calculate the block size. And when you can calculate the block size, then only you can solve the question. Then only you can find the network ID. When you have the network ID, you can find second network, you can find the range, you can check the first valid, second valid, network, broadcast. What is the maximum number of IP addresses that can be assigned to the host on a local subnet that uses this subnet mask? This subnet mask is going to give you how many IP addresses? If 5 host bits are there, 30.
30.
30.
You need to submit a network that has 5 subnets and each subnet with at least 16 hosts. What subnet mask could you like to use? If I need
C.
16 hosts and
240.
minimum 5
C.
subnets.
C. 240.
See, yeah, and you can apply it in formula as well. It should be greater than equal to 16. So I can find the H. Automatically I will get N. What is the subnetwork number of a host with an IP address 172.16.66.0/21? Tell me guys quickly now, we are late. We are going to start another topic. Network ID, subnet ID. Subnetwork number. How many bits are borrowed? And what is the subnet mask of last octet?
Five bits
21 means,
borrowed.
yes, 5 bit means 21 means in first octet 8, in second octet 8, in third octet 5.
5.
So what will be the subnet mask for 5 bits? 5 1 bits.
255, 255, 248.
248, then block size?
8 will be there.
Block size is going to be 8.
64 वाला होगा क्या? 64.0.
256 minus 248. Yes,
It's 8.
it is going to be 8. That means network ID is 172.16.64.0
Yes, sir. Yes, sir.
slash 21.
Yeah.
This is the
A
network
one.
ID. Which option is correct?
A wala.
A is the correct one. After this, you also need to solve some questions from book. Subnet the network 203.
Book you didn't share, Prabhu.
We'll share, bro. Don't worry.
Okay.
203.10.93.0/24 into 30 subnets. After that, after submitting, is this IP address valid host? Yes or no? So slash 30 means my subnet mask is 252. Block size is going to be 4. Block size is 4. Means my network ID is
93.0.
First of all, if I want to divide it into 30 subnet, how many bits I need to borrow? Sorry.
5.
5 bits. I need to borrow 5 bits. And for 5 bits, subnet mask will be what? For 5 network bits?
248.
248 means my block size is
8.
8 or 16? 8.
8.
Block size 8. Network ID of this IP address 8, 16, 24. 24 is going to be network ID, right? Dot 24, then 32.
32.
So this network is ending on dot 31. Now check, is this IP address in range? Yes, it is
Yes.
in range. So
Yes.
option A is the correct option. You are given the IP address 193.103.93.0/24 and you need 50 subnets. How many hosts per subnet and total networks do you get on subnet 8? Means how many subnets you will get after subnetting? 50. So 2 power n should be greater than or equal to 50. This is the formula for subnet. What should be the n? How many bits I need to borrow?
6.
I need to
6.
borrow
6.
6 bits. So
Answer is B.
if I will, yes, option is B. B is the correct answer. Right, because there is no any other option where 6 host bits are there. Sorry, this is not host, this is IP address. How you have calculated B, brother? If I will borrow 6 bits, then what will be my subnet mask?
Last D1 to host.
T. Yeah, two
To
host.
host.
Two host will be there.
D
Usable
option is
two
the
hosts will
correct,
be there.
right?
Yes. Yes, sir.
Your company has given the IP address 199.2.1.0/24 to subnet. You need to plan to put each of the 5 floor in your building on its own subnet. So in the building 5 floors are there and you need to keep each floor in their own subnet. What is the range of last available network once you subnet? After subnetting, what will be your last subnet? Yes.
So we divide that /24 into 5 subnets essentially.
So if I need 5 subnet, how many bits I need to borrow? 3?
Yes, sir.
3.
I need to borrow 3 bits, right? Then subnet
Yep.
mask will be 2 to 4.
2 to
Block size
4.
will be
32.
32, 30 usable hosts.
32.
Yeah.
First subnet
0 to 31.
/27.
Yeah.
1.0, then 1.32, then
Yeah.
1.64.
1.128.
Like this. Now tell me which option is the correct option. Last subnet.
You think C, no?
C.
C.
Yeah.
For all of you. Please check once.
Sir, you said like if we had borrowed 3 n equals to 3, then the block size would be 32. It is calculated on the basis of remaining hosts that is
Calculated based on subnet
easy.
mask. Block size is calculated based on subnet mask.
Okay, so we do try to have 5 subnets, then 2 power 5 gives to 32. You are just calculating like this.
Yes, I am calculating 256 minus subnet mask of last octet.
C is the answer.
C is the right answer. So I have discussed solution till 15 questions. 5 more questions are there. You can now try this question, but these are very easy question. You all can solve it. Now I am starting a new topic. Now leave subnetting for now. Again we'll come on subnetting. Now tell me the answer of one another interesting question, and which is very important for network engineers and very common question for network engineer interview. Why we come up with OSI model?
I guess OSI is the standard architecture of a network flow, like how data flows from client end to the network end.
So
just
before
to
OSI model there was no network. It means before
sorry, sir, I
OSI.
didn't hear you.
Okay, I'm saying it means before OSI model network was not there. No, network was there before as well, before OSI model as well. But before OSI model, you know, between the
To
vendors,
standardize the uh,
yes, between the
process
vendor
for the
devices was not able to communicate. Nowadays, with the help
OSI
of
is an open
OSI model,
standard.
yes, with the help of OSI model, you can see like different vendor devices are able to talk with each other. You have Dell laptop, I have HP laptop, someone has Apple laptop. They can talk, they can communicate. Why? Because the process which is designed for the communication to send data and receive the data is common in all networking devices, whether it is router or your PC or switch or firewall or access point WLC, any networking devices, your mobile phone, your printer, server. The process of sending and receiving data is standard, same. Got it? So
Sir,
we
one question, like,
go ahead.
who develops this OSI? Is it IANA or
Who
some other
develop
company?
OSI? Anyone have idea?
IEEE.
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 ISO.
IEEE.
ISO, yes, correct. IEEE, ISO. ISO
ISO
stand for
only.
what?
ISO only.
ISO stand for?
International
Organization
Standard
for
Standardization.
Standardization.
Good. And what you have understood why we come up with OSI? To make communication possible between all
Different
vendor
vendor
devices.
devices.
Yes,
Different
different
vendors.
vendor devices.
Different vendor compatibility.
Correct. What is the meaning of communication? Communication means sending and receiving data. For an example, between two any networking devices, between two PC only. So we have seen that if you want to send data from PC1 to PC2, there are some requirements. First, there should be some kind of media, right? Wired or wireless. For wire, we can have Ethernet, cable, and
Fiber optics cable as well.
yes, fiber optics cable as well. And on both the machines, I should have NIC.
You must have
Okay.
NIC, and that would have a IP address.
That must have MAC address first. That must have MAC address first, and then IP address. When both types of address is there and this media is also working fine, then they can communicate. You can send data, you can exchange data. But before exchanging data, computers have to structure the data, right? Let's suppose here I have one book, CCNA book. I want to send this CCNA book from PC1 to PC2. Can I send it directly? Can PC forward it from their NIC directly? If they will forward directly, and let's suppose in between PC there is switch, and switch is connected with many more devices. So how PC2 or any PC will understand that this data is for me? Or how any networking devices between PC1 and PC2 will understand that where to forward this data? It is same like sending letter without address, yes or no? So if there is no address in your letter, can postman deliver anywhere?
No.
No.
No,
Right? So like this
it
data
must have
need,
a proper address.
correct, this book need address to send PC2. Before sending PC2, PC1 have to add address here. And to perform some task on the PCC on network or on any networking devices, to perform any kind of task like adding IP addresses here with CCNA book PDF or MAC address is a task only, correct? Is some kind of task that PC need to perform. Task can be performed by two way in the network, manually or automatically. Static routing, dynamic routing. Static method of IP configuration, dynamic method of IP configuration. So for all the dynamic tasks, we will configure protocol. Protocol is what? Process which will perform some task dynamically. And OSI model make that protocols common. That protocol is going to be common. Like same protocol is adding the IP address or MAC address, whatever task is there. I will talk about the task as well. Before sending data, what task PC1 will perform. So what protocol PC1 is going to use to perform those tasks is common on all networking devices. Doesn't matter the vendor. So OSI model have just designed their own process of communication. Their own process of communication, because there was issue, different vendor devices was not able to communicate with each other. So we were looking for solution. So what ISO did, they create a common process of communication between two devices, that is like blueprint, and they have distributed to all manufacturing company that, bro, if you want to connect your devices, your hardware to the internet, then remember you have to design your hardware as well as software in this way. You can put any RAM, you can put any motherboard, any CPU, not matter. But the protocol for the communication is going to be this one only, right? So your OSI model is similar, like you can say a blueprint of some common protocols, group of protocols, right? And whoever are manufacturing the networking devices, whether it is PC, server, router, switch, or mobile phone, they will follow this blueprint. OSI model is again theoretical model. This is not the actual implementation. About actual implementation, we'll talk after OSI. This is just idea, theory, that okay, in this way we can make communication between all vendor devices, right? So OSI model is a task, some kind of task which PC performs before sending data and after receiving data. Like if you are going to send this book, CCNA book, to PC number 2, PC1 is going to perform some task. Like first task can be adding IP address with the data, source IP 10.1.1.1, destination IP here 10.1.1.2. MAC address of PC1 is A, MAC address of PC2 is B, right? So first task which PC1 will perform, PC1 will perform many tasks, but for now you know the IP addressing and MAC addressing, so I'm considering these two tasks only. Adding IP address with the actual data, source IP 10.1.1.1. I had told you the basic requirement of communication is 4 things.
Source MAC. Yes.
Source IP, destination IP, source MAC, destination MAC. So source IP 10.1, destination IP 10.2, source MAC A, destination MAC B. So before sending data from their NIC port, PC1 have performed this task. Now when PC2 is going to receive this data on the link, before giving you this CCNA book, PC2 have to remove this extra informations, right? Then only you can get the actual information. Like you will send letter to your friend. For your friend, important information is letter, information inside the letter, but it will reach to you through the envelope only, because on the envelope address is attached. It is similar like that. When PC2 is going to receive any data over here, it is going to verify first the MAC address, the destination MAC. Is it my MAC address or not? And all networking devices will accept the traffic in only two cases. Only two cases. If the destination MAC address is the MAC address of my receiving interface, or it is broadcast. Because if it is broadcast, then it can be for me as well, right? Definitely need to check more information. So PC2 will check, okay, destination MAC is my MAC address, means someone has sent traffic to me only. Then PC2 will remove this header. After that, it will check destination IP. That let me verify the destination IP as well. At layer 2, it is for me. At layer 3 also, it's for me only. Now let me check the actual data. Okay, this is CCNA book. It will hand over to the application. If I will talk about the PC and server, let's suppose here I have one PC which is connected with one server, Google server. Right? This is web server. We have one application here. Web server means which protocol? HTTP or HTTP as protocol is enabled. Port number 80 or port number 443 is running on this server. See, when you are typing any URL into the browser, means you are accessing what? Web page. Accessing web page is one service, but to access this service we are using protocol like HTTP or HTTP. For web access we have two protocol. To access this service we have two protocol. Similarly, to configure IP address on machines, this is what? One service, and we have one protocol to use this service, that is DHCP. Accessing networking devices remotely is what? One service, and to use this service I have protocol Telnet and SSH. Similarly, for web page we have two protocol to access web page service. So let's suppose PC1 is connected with server, and PC1 MAC address is A and server MAC address is B. PC IP address is 10.1.1.1, server IP address is 10.1.1.2 slash anything for now. And this PC has just opened their browser, any browser, and in the browser they have typed the IP address of server 10.1.1.2. What will happen? In the browser you type IP address, that means you want to access web page. You want to access web page. Which protocol will work behind the scene? Either HTTP or HTTPS. So the protocol is going to generate request, HTTP request message. It is going to generate HTTP request message. This protocol works at application layer. So at same layer, HTTP protocol is going to generate one message, right? This server can understand this HTTP request message. On both devices, this protocol is running HTTP and HTTP on the PC as well as server. So if I will talk about end-to-end communication, so service to service is going to actually communicate. Here HTTP is going to generate request, and on the server only HTTP protocol can understand that request. So many other protocol is also running. Let's suppose DHCP. DHCP protocol cannot understand this HTTP request message. Only HTTP can understand. Means application and application are going to exchange data messages, right? This HTTP protocol on the server can understand that, oh, hey, someone has requested me for the web page, let me send the reply message, right? If authentication is required, it will ask for username, password, credential. After that, like you will understand that as well, SSL connection, three-way handshake connection. But at the end, application to application are going to communicate on this server. Who can understand this HTTP request? Only this HTTP protocol. So I am assuming HTTP protocol is enabled on both the server, and now in the browser you have typed the IP address. Your machine will automatically generate HTTPS request message, and now your machine is going to perform all extra tasks. That is encapsulation, means adding extra information with actual data. Port number 1024, source port, destination port 80, source IP 10.1.1.1, destination IP 10.1.1.2, source MAC A, destination MAC B. These all are what? Encapsulation. Why I have added these informations? Why I have added these information?
Different layers have added those.
So that I can send it to correct device, right? Let's suppose if destination port number is not there, server cannot understand the traffic is for which protocol, because at application layer HTTP is also running, HTTPS is also running. Let's suppose telnet is also running, right? So port number is there to identify the service, IP address is there to identify the device host, right? And MAC address again used to identify the device within the LAN, within the local area network. So PC1 is performing these extra tasks to send the HTTP request message. When server will receive this request message, server is going to remove all the extra tasks, all the extra information, and it will give this information, actual HTTP request message, to HTTP protocol. HTTP protocol will understand it and it will generate the reply message. Again your server will perform encapsulation. It will add source IP, destination IP, source MAC, destination MAC, and then it will send to PC1, right? Just a minute. If I can find the PDF, what is network? Yes. Here, OSI model, Open System Interconnection Model, developed by International Standard Organization in 1980. After OSI model, now different vendor devices can communicate with each other, act as a blueprint, and these are the layers of OSI model. Now, I said OSI model is some kind of task. Task means performing some extra task to send the data. Why we divide that task into 7 parts? These are the layers. We divide the task into 7 parts. The same task, adding extra information with actual data. What is the benefit of division?
To
Why
make
we
things
divide anything?
simple.
Yes.
To make things simple.
Correct. If guys, lots of thing is going to happen and there is no any layers, we have not divided it, it is going to be even complex for me to teach you that how device is adding IP address, how it is adding MAC address, how traffic will flow between PC and server, because everything is mess up. So to organize it, we have divided into 7 parts, but this is task only, nothing else. At each layer are responsible for a specific task. Like you are in your home. Before leaving your home for office, every day you perform some task, brushing your teeth, taking bath, right, taking car key, lunch, and then you are leaving your home. In the same way, PC is performing some task before leaving the interface, and those task is called OSI model. And to make it easy, we divide it into 7 parts, right? Otherwise it will be difficult to understand where traffic is getting generated, where IP address is getting attached, where port number is going to getting attached, where MAC address is getting attached. That's why we divide it into 7 parts, and they give name to each layers. First layer is application, then presentation, then session, then transport, then network, then data link layer, and then physical layer. Anyone have idea about these layers? Application layer, any idea about application layer?
Yes, sir. Yes, sir. It acts as an interface between user and the actual data or
Application layer is nothing but user interface. Application layer is user
It's where
interface
that
between,
user data is presentable and readable.
yes, between user and actual application. Like you can see this browser or Google Chrome. Google Chrome is an interface between Google server and the actual user, yes or no, through which you can access the web page, google.com, facebook.com. So what is this? This browser is, Google Chrome is application, right? Interface. Without app interface, you can't access any service. Putty is also one interface. CMD is also one interface. This all works at application layers. Presentation layer. See, it's clear with their name only. Present the data, right? It is responsible for tasks like encryption, compression. See, you all must have seen that sometime when we are sharing file with our friend over mail or over WhatsApp, sometime it is going to give you the error that file size is large. You are only allowed to send, let's say, 10 MB file, right? Let's suppose you have a small video and you want to share that with me, but WhatsApp is not allowing you to send that file because file size is larger than WhatsApp can send. Then what you will do? Then what will you do? You will
Either
compress it.
break it, yeah, compress it, or make parts of it.
You will compress it, right? Like zip file. There are so many tools to compress the data. Compress means what? Just reducing the size, compressing something to reduce the size. But when receiver will receive, receiver have to decompress. So we have presentation here so that devices can automatically perform compression and decompression if it is required, right? Some application can have inbuilt feature of compression and decompression. So which layer will be performing compression and decompression? Your presentation layer only. Similarly, some data should not be travel in plain text, right? Like I I am sending one message or a letter to my wife. But I am going to send it through my dad. I'm going to send it through my dad. So my dad can read it, right? I don't want that. What I can do, I can encrypt it. I can change the words. Instead of this, I can say 1, 4, 3. 1, 4, 3. So what I did here, I use one algorithm. See, are you guys able to see algorithm which I have used?
No. Yes.
What algorithm? Based on number
Number
of
counter.
words in the
Number of words.
yes,
Number of
based on
letters.
letter in the words, I have used numeric value, right? Like at first place I have only one letter, so I said 1. In second words I have 4 letters, so I said 4. In third word there are 3 letters, so I said 3. Now my wife should have this algorithm that I means always 1, love means always 4, and you means always 3. If my wife has this algorithm and I also have this algorithm, then we both can talk. But my dad, for my dad, what is this? This is what?
It's just
Encryption.
random string.
Yes.
Yeah.
This is encryption, right? Like by using encryption, by using any algorithm, you can encrypt your data. So many tools are available on the internet. After the class you can try, like you will put the data and it will give you the another data, the encrypted data. Again you can convert back. So PC1 and PC2 or PC and server, PC1 will perform encryption and server will perform decryption. Only possible if both have the same algorithm. So both the machines, hardware and software, are designed based on OSI model, right? Both are designed based on OSI model. So default encryption will be always decrypted by receiver device. But which layer is responsible for that? Your presentation layer, encryption and decryption. 4 important functions of presentation layer is compression, decompression, encryption and decryption. Sender machine will perform compression and encryption, and receiver machine will perform decompression and decryption, right? But you know, out of these 7 layers, as a network engineer you are not going to work on application layer, even you are not going to work on presentation layer, you are not going to work on session layer. Your work will start from transport layer. Transport layer is the height of OSI model and height of networking as well. And network layer is the height of network. Right? You are going to perform most of the task at transport layer, network layer, and data link layer, and then physical layer. Physical layer. So for network engineers, see, we have divided OSI model into 2 parts, upper layer and lower layer. These 3 layers, application, presentation and session, are called upper layer, and these 4 lower layers are called lower layers. Who works on these upper layers?
Developers.
Software.
Software engineers, yes. Developer, tester. And who works on these 4 lower layers?
Network engineer.
Network engineer.
Correct.
We
You, we are going to work on these layer, but you should have basic idea about the application as well, right? But if application is not working, you will not fix it, you will not troubleshoot it. If there is issue in application, there will be a dedicated team for that. But if application is not accessible because of network, that means issue is not in application, issue is here. This is the reason why we divide OSI into 7 parts, so that we can categorize not only the task, but we can categorize the functions of network. It will help you to troubleshoot the issues. Even whenever you will troubleshoot the issue in network, you will use OSI layers. You will always troubleshoot in sequence. You will start troubleshooting from physical layer, data link layer, network layer, and transport layer, right? For now, let's suppose here this PC is complaining I am not able to access HTTP application. You know what's your task? You have to verify that application is accessible from this PC. But PC is saying not able to access application. How I can verify? You can verify it like you can use telnet and the IP address 10.1.1.2 and the port number 80. It will tell you that port number is open or not. Means port number is open. This is the last thing which you will verify. Most of the time you will check connectivity, that is PC1 able to ping PC2. If yes, that means network is fine. But maybe your firewall or any device is blocking the port number, right? Because of that application is not working. Then software engineer cannot fix it. You have to fix it only. So this way you can check the port number is accessible from PC1 or not. Apart from this, if here I am able to see port number is open, that means this is the last thing which I can do. Then I can't do anything. Software team have to solve it, fix it. Right? Now, application layer, user interface, presentation layer responsible for encryption, decryption, compression, decompression. Session layer, what is the responsibility of session layer? Session layer keep the session separate, like you can see in this browser. How many tabs are running? WhatsApp, Google Meet, and one more tab, Google. So my PC has sent a request to the Google server. Google server has responded with reply message to my PC. How my PC got to know that I need to put the reply in this tab only? Not in this tab. Not in this tab. It have put it the reply in this tab with the help of session layer. Session layer is going to keep the track of session. Like, see, if this PC is trying to access HTTP. So whenever your PC is going to send HTTP request message, session layer is going to note down the time, right? Let's suppose it has sent the message, request message right now, and session layer has noted the information that I have sent one HTTP request message to server, and HTTPS or HTTP timeout is 5 seconds or 1 minute. So within 1 minute, if your PC will not receive the response message, session layer is going to give you the error, session timeout, right? So who has the track of request and reply? Session layer. Session layer will keep track of each and every session between source and destination. Between source and destination. So here also you can read about application layer. Application layer acts as a interface between user and actual application. This layer tells us the application is internet based or not. Yes, if you need to send book between PC1 and PC2, internet is not required. If I am going to send book between PC1 and PC2, or I am going to access any data, right, internet is not required. If I'm sending a movie from PC1 to PC2, is internet required? Not required. So the application which you will use to send the book will tell to PC that internet is needed or not. There are various services like web access, file service, remote access service, time service, mail service at this layer. These are common services at application layer, and these all services can be accessed with the help of some protocols like HTTP, TFTP, HTTPS, Telnet, SSH, SNMP, FTP, DNS, etc. App developers design these protocols, right? So see, some services and some protocols to access those services. We don't need to understand these services, but we need to understand these some application layer protocols like DNS, FTP, SMTP, Telnet. These are networking protocols, right, used in network. So you have to learn these protocols. In packet tracer, let's suppose I want to create a small lab of Google server. Let's suppose this is my PC and here is a Google server. Packet tracer is, guys, great simulation for these kinds of lab. Like you can configure this server as web server. All the services are even available. As one, I can say web server. Here you can see, click on services, you can see all the services. HTTP, by default HTTP service is enable or disable? Enable, on. Here you can create the website. If you have idea about the HTML coding, you can create the website. Instance of Cisco packet tracer, here I can say PM networking. Right, welcome to Cisco packet tracer, welcome to PM networking. This is HTML coding, right? You can edit it, you can just copy and remove it, and you can paste your own code. CCNA CCNP, like I am changing some words, that's it, and save it. So HTTP service is by default enable. I have configured the website, I have designed the website over here which is hosted on this server. If I want to access it from this PC, first of all there should be reachability. MAC addresses are already there, but you have to configure IP address, correct? On PC1 I can say IP address 10.1.1.1 and 255.255.255.0. gateway is not required. On server desktop IP address 10.1.1.2, 255.255.255.0, gateway is not required. That's it. From PC1 you can open the browser because you need an interface. So web browser is there, and in the web browser right now I don't have DNS. Later I will integrate the DNS, then I will put the domain name, not the IP address. For now I am saying IP address 10.1.1.2, and you can see I got the website access, right? And if you want to see what happened behind the scene, you can use what? Simulation mode. Through simulation mode you can check each and every information which is steps, process which is happening behind the scene. So my service is HTTP, my web service. For that my protocol is HTTP. To access web service I have used HTTP protocol. Like this we will discuss these all protocols, okay, and we will configure it as well. We will have lab. Presentation layer, you can see it is just performing encryption, decryption, compression, decompression. Session layer, create, maintain and terminate session with the help of session ID. And then your transport layer, the actual networking is starting here. Transport layer. Now we are going to learn these three layers first in detail, and after that I will come on all application layer protocols and services. So see, before transport layer, here I have put port number. Who can tell me what is port number? What is?
The service, particular number that service is working on.
On application layer, I told you, I said some services are there, and to access that service, some protocols are there. And each and every application layer protocols uses a unique identity, right? Like how you can identify the service, how you can identify the protocol. For that, every application layer protocols uses a unique identity called port number. That port number is nothing but the unique identity of application layer protocols, like your HTTP port number 80. Here in OSI model, I said your networking is starting here at transport layer. How transport layer will understand the actual service, right? Because through network engineer, you are the network engineer in the company. You know what you will do? You will send data from PC1 to this server till transport layer. Till transport layer, you will take care of everything. And transport layer will check port number to identify the service, and then it will directly send that request message to that protocol. So you are going to, network engineer is going to send message with destination port number 80 at transport layer. At transport layer, it will check destination port is 80. Let me check HTTP protocol is running or not. If it is enabled, then let me remove rest all the information, whatever information was required for networking, and let me send the actual data to HTTP protocol. Right? So this is unique identity of your application, each and all every application. And there are two types of port number. Port number like IP address is a 32 bits address represented in dotted decimal. MAC address is 48 bits address represented in hexadecimal. Similarly, port number is 16 bits. 16 bits. Which value? Represented in decimal. 16 bits decimal value. So range will be what, guys? Range will be what? A port number
12655.
0 to 2 power 16. This is range, right? 2 power 16 is going to be 6 5 5 3 3 4 5
5 3 5
5 or 4 5. Total 6 5 5 3 5 port number are there from 0 to 6 5 5 3 4. Total how many port numbers are there? 6 5 5 3 5. These are total port numbers. 0 to 6 5 5 3 4. Out of these port numbers, some port numbers are reserved, which we have already assigned to protocol. Like see, HTTP is using port number what? 80. That is reserved for HTTP. We can't use that port number. That is reserved for HTTP. So port number is divided into two parts. Port number is divided into two parts. First one is called well-known, and second one is called unknown or free. Well-known and unknown. Well-known are those port number which we have already assigned to the protocol, which we have already defined to protocol. And what is the range of well-known port number?
0 to 10 to 3.
This is the range of if you will check port number of any application layer protocol, you will see port number is from this range only. Let me show you. HTTP, what is the port number? 80. HTTPS, what is the port number? 443.
443.
DNS, what is the port number? 53.
53.
DHCP, what is the port number?
67, 68.
67, 68. BGP, what is the port number? 179, right? So any protocol, you can check any protocol which works at application layer will be using one port number from this range, and rest all the port numbers are free. 10242 65534. These all are free port numbers. From PC1, if I am going to send HTTP traffic again, before that let me use simulation mode here. What happened? .1.1.2, enter. Here you can see the message, open it. In the TCP header, you can see source port number is from which range? From the free range, right? And destination port number? It is well known. Well known port number means what? It means, see, if you are going to access google.com, destination port will be always what? Either 80 or 443. But about the source, is source fixed? No. You can access Google from your mobile phone, from your laptop, from another device, from any device you can access the Google. So source is variable. For source, we have this free range of port number, right? Your device can use any port number from this range for source port, and destination port will be always well known. In this case, if PC1 is going to send traffic HTTP request message to the server, what will happen? See, this is very important for packet flow. Then only you can understand packet flow. So till now what we have seen, that once I will browse this IP address in the browser, my machine is going to generate HTTPS request message. Am I right? Then it will send to transport layer. It will send to
transport layer.
This application works at which layer? At application layer. So at application layer, HTTP protocol is generating this request message, right? After that, application layer will send it to lower layer, presentation. Then presentation will send it to session, and session will send it to transport layer. And your transport layer is responsible to add
port number, source and destination
with yes, actual data. So source port number, what I told you, any random port number 1024, destination port number
443.
Yes, 44443, correct. Right. Some more informations will be there. I will talk about that later. Then transport layer will send data to
network layer.
Lower layer, network layer. Network layer is responsible to add
source and destination IP.
Source IP and destination IP. Source IP is
110.1.1.
And destination IP
1.2.
Then network layer will hand over this to
data link
layer, and data link layer is responsible to add
source and destination MAC.
Source MAC and destination MAC. Source MAC A, destination MAC B. But adding extra information with actual data is happening automatically, right? That means some protocol is running behind the scene. At transport layer, the protocol which is running behind the scene can be TCP or
UDP.
At network layer, to add IP header, protocol can be IPv4 or
V6.
IPv6.
right. A data link layer, if the link is Ethernet link, then protocol is going to be
ARPA.
Very good. So these protocols are running at this layer. We need to learn and master. At transport layer, we will discuss TCP UDP protocol. At network layer, IPv4 protocol. Means there will be many more information except source IP and destination IP. So we will talk about other fields also. Similarly, in the Ethernet header and transport layer. And this particular thing is called adding extra information with actual data is called
Encapsulation.
yes, this
Encapsulation.
particular thing is called encapsulation, right? And when PC1 will send it to server, server will receive at which layer? Server will receive it at physical layer. Physical. Now you know here on PC number 1 what will happen? Data link layer will hand over it to physical layer, and your physical layer will convert this into bits, then maybe into signal or light, depending on the media. Depending on media, it will convert it. You convert your data into the signal or into bits, and it will send bits by bits to server. Server will be receiving data at physical layer. Again, physical layer will convert bits into frame. Right? At data link layer, we call data to frame. At network layer, we call data to packet. At transport layer, we call data to
Segment.
segment. Right? Segment means actual data plus transport layer header. Getting my point? Packet means the data payload plus network layer header. Frame means again data actual payload plus data link layer header. Data link layer header. Right? So at server, physical layer will receive the bits or signal. It will convert it into frame and hand over it to data link layer. Data link layer is going to receive frame. Frame means data at layer 2 means this header is there, and after that these will be considered as payload. Rest all the information except layer 2 header will be considered as data payload. So data link layer is going to check, hey, what is destination MAC? Is it my MAC address? If yes, then data link layer will remove it, this header. It will remove this header and it will hand over to upper layer, network layer. Network layer is going to check destination IP. Is it my IP address? If yes, it will remove it and hand over to upper layer, transport layer. Transport layer is going to check destination port. Is this port number enabled? If yes, it will remove it and send this actual request message to HTTP protocol. Right? So your OSI model, sometime in the interview or anyone can ask you which layer is application layer, right? Which layer is physical layer. So see, on the sender machine, first layer is application layer where data will be generated. Then presentation, session, transport, network, data and physical. But on the receiver machine,
Physical layer will be 1.
yes, on the receiver machine,
Physical will be 1. Application will be 7.
Yes.
Application will be 7.
Yes. It physical is going to be 1, physical, data link layer, network layer, transport layer, then session layer, presentation layer and application layer. Here is the sender device, and here is the receiver. Sender, receiver. How data will travel? Sender machine will generate traffic at application layer and it will goes to physical layer. Physical layer will send it to receiver machine. It will transmit the data from the physical link from the media, and receiver machine will receive it, and receiver machine is going to process it from physical to application. Getting my point?
Yes.
If communication is not working in this way, only you will troubleshoot. Right? In tomorrow class, we'll structure data in more better way. We'll talk little bit more about these layers and headers, and after that I will show you the complete packet flow. Before packet flow, you will be knowing everything. In packet flow, you will be answering me that how packet is going to flow. Okay. Now, see, about the OSI model, you don't have any task for now. You do not need to learn even as well. So do one thing, solve the subnetting questions from the PDF and check some questions in your book once. I am going to share book soon on the drive. Okay. So I think book is shared with some of you guys, right? Kabia has shared with some of you. I've given you the access to the drive folder. Okay.
Excuse me, sir. Can you please I don't know if I don't think I'm added because I'm not getting the
No problem, no problem.
latest videos and materials being shared.
No
And
problem, no
I
problem. See, if you are
sent my
adding,
email already.
if you are not receiving anything, just put message on WhatsApp.
Okay.
Okay. So just practice subnetting before next class, because from the next class you will not have time to check the previous topic. Now you will be very busy in the packet flow, and after that quickly we will start the switching. So I will start assigning you the labs, but I want you guys to practice to have good commands on subnetting. Subnetting is very important topic.
Do we get a lab access, the one you're hosting? Uh, do we have a lab access
Which lab
that we
access?
can access? I mean, you're hosting a lab as a part of this course where we could access your lab,
No,
or
you,
just
you can't access that lab. You have to set up your own lab.
Oh, okay.
Right? And one more thing, I had asked you guys to set up the EVNG in your laptop.
Do we have instructions on how to do that?
I had shared the video yesterday.
The video that is shared this morning,
Yesterday I had shared in the chat, right?
where?
So if anyone have not installed the EVNG, please set up it. Right now we are going to use EVNG as well in the switching, just after 3 to 4 classes. Before that you all should have EVNG. If anyone is stuck somewhere, you can let me know.